Let's talk about classifying matter. So matter can be broken up into two categories, things that are pure substances and things that are mixtures. Each one of those can be further broken up. Mixtures can be either homogeneous or heterogeneous. Pure substances can be either elements or compounds, and compounds can be broken down even further. So what's going on? So we begin with atoms. That's our building blocks. And what can they do? Well, they can bond. So they can bond together, two of the same atom bonding together, or they can bond with other types of atoms, so a green and a red. Also, they can bond in different ratios. If there's different types of elements and atoms, they can bond 1 to 1, 1 to 3, 3 to 1, 1 to 2. Also, you can take any one of these things and mix them together. But there's two ways you can mix them. You could mix them uniformly so that it's evenly distributed, or non-uniformly so that in different areas you have different amounts of the substances. Our job in chemistry is to be able to classify substances as one of these types of things. Okay, so if we look at the particles, we can classify them pretty easily. We're going to define pure substances as substances that are composed of just one type of particle. So I'm showing 4 different examples of pure substances here. In the upper left, we have just red atoms. In the upper right, we have things that are bonded together, but they're bonded in the same kinds of set. Every one of those particles is 1 blue and 2 reds. Similarly with the ones on the bottom. Mixtures, on the other hand, are composed of more than one type of particle. So we see in the upper corner, we have the green types of bonded together, or the red-blue mix. And in the bottom, we have the 2 different types of particles. Okay, so now let's go back and just talk about the pure substances. These mean that each pile has just one type of particle in them. If it is composed of just one type of atom, it's considered an element. So in the top left, we have individual atoms. In the bottom left, it's still considered an element because although there are 2 of them bonded together, they're still just one type. They're both green. On the right-hand side, we have compounds. Compounds are composed of particles that have more than one type of atom in there, but they're bonded together, not mixed together as in a mixture. So here's some examples. I can then go back and talk about the mixtures. Remember, the mixtures have more than one type of particle in them. Homogeneous mixtures are ones that are uniformly mixed. If I were looking at a large amount of a homogeneous mixture, I wouldn't be able to tell that there's more than one type of particle in them. It would look like one thing because it's uniform. Heterogeneous mixture, on the other hand, are not so uniformly mixed, and you can usually tell just upon looking at it that there's more than one component in there. So I can also, we talked about those 2 kinds of elements. We do refer to the ones that are just individual atoms as atomic elements, and most elements are that type. And then sometimes they'll bond together in pairs. Those are called diatomic elements. There are 7 elements that always form diatomic element pairs, molecules, and we call them molecular elements. We'll talk about which 7 they are at a later date. But you can't see particles, so normally classifying matter is a little bit trickier. In bulk, it's a little bit harder to do. So, for instance, we have bronze, we have something that's blue liquid called aqueous copper 2 sulfate, we have water, we have sodium chloride. How do I know whether these are pure or mixtures, or whether they are elements or compounds? So I can try to find some stuff about them. So for instance, bronze is made from heating tin and copper together. So I know that it has tin and copper in it. It has 2 different elements in it. Aqueous copper sulfate is made from adding copper 2 sulfate to water and mixing it. So now I know that there's copper 2 sulfate and water in there. Water can be made by reacting a mixture of hydrogen and oxygen gases, but they're a chemical reaction. Sodium chloride can be produced in a chemical reaction of chlorine gas and sodium metal, so that's definitely got two elements in it. Also, I think about separation methods. For both bronze and aqueous copper 2 sulfate, I can separate them. Bronze can be separated back into copper and tin by careful heating by a process called liquation. It's not easy to do, but it can be done. And aqueous copper sulfate can be separated if I sit it on a hot plate and I allow the water to evaporate off. The water will leave and I'll be left with just copper sulfate solid again. So when I'm looking at bulk, I want to figure out how can I distinguish what it is. So if I'm looking at it visually and I can see that there are two or more components, I know for sure it's a heterogeneous mixture because I can see the two components. However, if it appears to be one component, it's tricky. I don't know whether it's an element or a compound or a homogeneous mixture just by looking at it. I'm going to have to do some more digging. I can do some elemental tests. We can use mass spectroscopy. So if mass spectroscopy shows that there's only one element in it, then it's an element. But if it shows there are more than one element in it, then I know it's either a compound or a homogeneous mixture. The difference being that a compound will always have the same ratio of the elements. So if I take multiple samples and keep running them and the ratio of one element to the other is always the same, then it's a compound. Additionally, I can look for separation. Mixtures can be separated, but compounds cannot be separated. So I can try to, if I can separate it by filtering it, distillation, evaporation, I might use magnets, all sorts of techniques, that liquation we talked about, then it could be a mixture. So it's kind of tricky. Let's try this for practice. On the first side, I have a list of items, and I want you to first think about, is it a pure or mixture? We'll do the first classification, and then I want you to classify it further. If it's a mixture, tell me whether it's homogeneous or heterogeneous. If it's a pure substance, tell me whether it's an element or a compound. You'll do that for your checkpoint. On the right-hand side, I have which of these elements. So I want you to look at these and try and discern from the name if it's an element or if it's not an element. In summary, when we classify matter, we're really talking about elements, compounds, and mixtures. Elements at the particle level are all the same type of atom. Their chemical formula would be just a single chemical symbol. If it has a chemical name, it will be a name of an element. We have 115 reserved names. It would be one of them. Compounds, on the other hand, if I look at the particle drawing, I would see that there are two or more different kinds of elements bonded together. And in the chemical formula, I'll see two or more chemical symbols in the chemical formula. And in the name, I will often see parts of two different element names. Now, there may be extra things like carbon dioxide has carbon, and it has a part of the word oxygen. Both of those are elements. That's indicating a compound. Mixtures, on the other hand, are the things, if you can't identify it as an element or a compound, it's very likely a mixture. Again, if I could see a picture of it, I would see different kinds of particles. You can't write a chemical formula for a mixture, so that's an identification in some way. And there are no chemical names. It won't have element names in them. They might have reserved names, but they won't have a specific elemental chemical name. And mixtures can be separated. That's one of our techniques.